The other force we're going to look at in this chapter is the force of friction. And friction is going to be divided into four different types. However, there really is only two. It's just the way the book does it. But what is friction? Friction is going to be the force exerted when two surfaces exert a force or rub against each other. In general, a smooth surface tends to have less friction than a rough surface. So if you can think about riding your bike, in order for your bike to move, your tire has to exert a force on the road, and the road has to exert a force, therefore, on your tire that is equal in magnitude but opposite in direction. The rubbing of those two forces is considered the friction, or the rubbing between those two surfaces is considered the friction. If you decide to brake your bicycle, if you brake the front tire, then the front tire stops moving. The brake pad rubs against the actual brake disc and slows down, exerts that force of friction on your tire, slowing it down eventually to a stop. The tire therefore also exerts a force on the ground, slowing it down till eventually it stops. And you'll note that Newton's first law will also take an effect if you only use the front of your front brake, because the back of your body, which is moving at a constant velocity, will continue to move at a constant velocity, even though you didn't apply a unbalanced force to that. And that's normally when you flip over your handlebars, because the back keeps moving. There are two causes for friction. And they're going to be, well, there's going to be, the cause of friction is just surfaces rubbing on each other. The two factors are going to be how hard those surfaces push together and what types of surfaces are involved. The biggest thing to note here is that friction is always going to oppose direction. So if I have this block moving on a surface, the friction between the ground here and the block is going to want to slow that object down in the opposite direction that motion is. So friction and motion are always going to be countering each other. Your book again goes into four different types of friction. However, these last three, sliding, rolling, and fluid friction, are really kind of the same thing. It just depends on a change in surface. Static friction, which is probably the most confusing one of the bunch, deals with what static means, and static means like stopping or preventing from moving. If you ever go rock climbing, I don't know how many of you go rock climbing, but you use different types of ropes when you go rock climbing. A static rope would be one that doesn't have any give to it. So when you fall on a static line, it hurts a lot more as opposed to a dynamic line, which would kind of bounce you there. Static, it's not going to have any stretch to the rope. It's going to be whatever it is at all times. The other three, the sliding, rolling, and fluid friction, are what we refer to as kinetic friction, and those are dealing with movement. So here we have motion for these three. In static, we do not have motion, so our object is at a rest for static friction. So static friction, it acts on objects that are not moving, just like the word static means. Because of static friction, you have to exert extra force to start an object moving. If you ever decide to go and push your buddy's car around, if it breaks down or it's manual and you have to pop start it or something like that, you got to exert a lot of force to get it moving. Once it gets moving, though, and you've overcome that static friction, you don't have to exert the same amount of force. You can exert less. That's static friction. It's also the friction that if you like set a block on a ramp or something, the block doesn't move, it doesn't fall down that ramp like gravity would want it to, then it's probably because the force of gravity is not overcoming the static friction between the block and the ramp. Sliding friction is a type of kinetic friction. Kinetic means moving. So this is when two surfaces slide over each other. You can think of that as when you go sledding. You sit on the sled slides across the snow. The friction between the two surfaces, again, is going to oppose motion. So if you have very rough snow, it doesn't go too well, but if you have like a sheet of ice, it'll go a lot better. The friction does oppose the motion of it. So here we do have friction acting in this way, and then the gravity of the going downhill is going to act in that direction. or if you decide to push off into that direction as well. Rolling friction is going to be when you have wheels involved. Again, it's pretty much the same thing as sliding in fluid, but in this case, our one surface is kind of rounded like a wheel. Here, the force is being exerted here, where the tire hits the actual ground. According to like air-filled tires, it'll be flattened out in order to increase the grip as that happens. One of the reasons why tires with air in them work better than if you just had a solid block. One, you can get more friction out of it, and two, the air actually allows it to grip around things. You don't feel every bump as you go across it from the other surface. But again, here, if my tire is moving in this direction, friction is going to be opposing that direction. A lot of times you add wheels to things to reduce your sliding friction so you can move things easier. Like if you're moving furniture or something, you can put little die cast wheels on the bottom and therefore you can push it around easily, as opposed to having furniture without die cast wheels, which is probably meant to be stationary and not moved around very easily. Fluid friction is the last type that our chapter goes into. And again, this is a solid object moving through a fluid. That fluid is either a liquid or a gas. So keep in mind, your plane flying through the air is actually experiencing that air resistance, which is a type of fluid friction. Again, as it flies through the air, the particles in the air are going to smack against it, exerting a force on that plane and push it opposite of whatever way it's moving. Another example of fluid friction would be like liquids, such as WD-40, which is an oil that you can like spray on a bolt or something. So instead of having the sliding friction between the bolt threads and the casing that it's in, you can have it between the bolt threads and a layer of liquid, which is the WD-40, and therefore makes it less friction and easier to get things moving in that sense.